What if I told you that technologies you see in sci-fi movies aren't as much of a distant future as you might think? What if I told you that less than a century from now, you'll see telecommunications only witnessed in movies like Star Wars or Total Recall? Today, we can communicate with the internet via our computers and cell phones. But in the future, the web will be everywhere. In wall screens, furniture, on billboards, and even in our glasses and contact lenses. When we blink, we will go online. There are several ways we can put the internet on a lens. The image can be flashed from our glasses directly through the lens of our eyes and onto our retinas. The image could also be projected onto the lens, which would act as a screen. It might even be attached to the frame of the glasses, like a small jeweler's lens. As we peer through the spectacles, we see the internet, as if looking at a movie screen. We can then manipulate it with a handheld device that controls the computer via a wireless connection. We can also simply move our fingers in the air to control the image, since the computer recognizes the position of our hands as we wave them. Since 1991, scientists at the University of Washington have perfected the virtual retinal display, VRD, in which red, green, and blue laser lights are shown directly onto the retina. With a 120-degree field of view and a resolution of 1600 by 1200 pixels, the VRD display can produce a brilliant, lifelike image that is comparable to pictures taken from the most cutting-edge modern technology. The image can be generated using a helmet, goggles, or glasses. A much more advanced version would have the web flashed directly through our contact lenses by inserting a chip and LCD display into the plastic. Current Vice President of Amazon, Babak Parviz, and his group at the University of Washington, between 2003 and 2012 in Seattle, laid the groundwork of the internet contact lens, designing prototypes that eventually changed the way we access the internet. He foresaw that one immediate application of this technology might have been used to help diabetics regulate their glucose levels, for example. The lens would display an immediate readout of the conditions within their body. But that was just the beginning. Eventually, Parviz envisions the day when we will be able to download any movie, song, website, or piece of information off the internet into our contact lens. We will have a complete home entertainment system in our lens as we lay back and enjoy feature-length movies. We can also use it to connect directly to our office computers via our lens, then manipulate the files that flash before us. From the comfort of the beach, we will be able to teleconference the office by blinking. By inserting some pattern recognition software into these internet glasses, they will also recognize objects and even some people's faces. Already, some software programs can recognize pre-programmed faces with over 90% accuracy. Not just the name, but the biography of the person you are talking to may flash before you as you speak. At a meeting, this will end the embarrassment of bumping into someone you know whose name you can't remember. This may also serve as an important function at a cocktail party, where there are many strangers, some of whom are very important, but you don't know who they are. In the future, you'll be able to identify strangers and their backgrounds even as you speak to them. This is somewhat like the world seen in the robotic eyes of the Terminator. This may alter the educational system. In the future, students taking a final exam will be able to silently scan the internet via their contact lens for the answers to the questions, which would pose an obvious problem for teachers who often rely on rote memorization. This means that educators will have to stress thinking and reasoning ability instead. Your glasses may also have a tiny video camera in the frame, so it can film your surroundings and then broadcast the images directly onto the internet. People around the world may be able to share their experiences as they happen. Whatever you're watching, thousands of others will be able to see it as well. Parents will know what their children are doing. Lovers may share experiences when separated. People at concerts will be able to communicate their excitement around the world. Inspectors will visit faraway factories and then beam the live images directly to the contact lens of his boss. Or one spouse does the shopping while the other may make comments about what to buy. Parvis has been able to miniaturize a computer chip so that it can be placed inside the polymer film of a contact lens. He has successfully placed an LED into a contact lens and is now working on one with an 8x8 array of LEDs. His contact lens can be controlled by a wireless connection. He claims those components will include hundreds of LEDs which will form images in front of the eye, such as words, charts, and photographs. Much of the hardware is semi-transparent, so the wearers can navigate their surroundings without crashing into them or becoming disoriented. His ultimate goal, which is still years away, is to create a contact lens with 3,600 pixels, each one no more than 10 micrometers thick. One advantage of internet contact lenses is that they use so little power, only a few millionths of a watt, so they are very efficient in their energy requirements and won't drain any battery. Another advantage is that the eye and the optic nerve are in some sense a direct extension of the human brain, so we are gaining direct access to the human brain without having to implant electrodes. The eye and the optic nerve transmit information at a rate exceeding a high-speed internet connection. So an internet contact lens offers perhaps the most efficient and rapid access to the brain. Shining an image onto the eye via a contact lens is a bit more complex than for the internet glasses. An LED can produce a dot or pixel of light, but you have to add a micro lens so that it focuses directly onto the retina. The final image would appear to float about 2 feet away from you. A more advanced design that Parvis is considering is to use microlasers to send a super sharp image directly onto the retina with the same technology used in the chip industry to carve out tiny transistors. One can also etch tiny lasers of the same size, making the smallest lasers in the world. Lasers that are about 100 atoms across are in principle possible using this technology. Like transistors, you could conceivably pack millions of lasers onto a chip the size of your fingernail. But all of this technology we're talking about, having direct contact with our brain, isn't it harmful to our vision? Will this device open our eyes to see the world closer? And is it going to fasten the process of blinding people? To find out, come with us to the next video referred to this topic. And don't forget to join our journey by subscribing to our channel.